Voyager 1 is currently moving through the dark, freezing vacuum of interstellar space, further from its origin than any object in history. This machine launched in 1977 to tour Jupiter and Saturn. Decades later, it passed the heliosphere to enter the interstellar environment in 2012. Its hardware is 1970s engineering, operating nearly 50 years into a mission designed for a fraction of that time. The probe is traveling at roughly 38,000 miles per hour, pushing into a region of space where no other human artifact has ever sampled the environment. It is currently more than 164 astronomical units from Earth, a distance so vast that traditional units of measurement begin to lose their meaning. The ongoing communication from such an extreme distance is the central paradox of the mission. Voyager 1 transmits a radio signal far weaker than its interstellar reputation might suggest. The spacecraft broadcasts with approximately 20 watts of power, roughly the same energy required to run a standard refrigerator light bulb. This faint signal must cross billions of miles of empty space, losing almost all of its amplitude as it radiates toward our planet. The success of the mission depends on planetary-scale infrastructure on Earth, designed specifically to catch this whisper against the background noise of the cosmos. NASA's Deep Space Network serves as the primary listener for these transmissions. Massive radio dishes arrayed across the globe actively strain to resolve the spacecraft's data from the static of deep space. Because of the distance, a single radio signal requires roughly 23 hours to travel one way at the speed of light. On November 18, 2026, the spacecraft will reach a distance of over 16 billion miles from Earth. At this specific threshold, the communication delay will reach exactly 24 hours. Reaching one light day represents a boundary where human communication meets its absolute physical and temporal limits. Maintaining this signal requires a steady sacrifice of power as the probe's nuclear source decays further each year. Engineers are managing this loss through a triage strategy, systematically putting the craft's systems to sleep to preserve its remaining wattage. This process led to the shutdown of the low-energy charged particles experiment on April 17, 2026. This shutdown followed a pre-planned sequence established by scientists years ago to protect the craft's most vital systems. Every day of continued connection is bought by sacrificing pieces of the craft's functionality in a persistent war of attrition against time and physics. The current science of Voyager 1 focuses on data collection rather than the symbolic messages of its early years. The Golden Record is a silent passenger, carrying a cultural message for the future. Today's active mission transmits raw telemetry back to Earth. The instruments are currently measuring plasma, magnetic fields, and cosmic rays within the interstellar medium. This trickle of data provides the only first-hand evidence of the universe beyond the protective influence of our sun. Humanity evolved on a single planet, yet we now actively operate an artifact in interstellar space. This connection acts as a literal tether spanning billions of miles of darkness. The thread remains intact through engineering willpower and massive ground-based architecture. This ongoing conversation stands as a monument to human ingenuity, bridging the gap between our planetary origins and the deep cosmos. Eventually, the onboard power will drop too low to sustain the transmitter. The remaining instruments will shut down, the signal will stop, and the deep space network will hear nothing but the static of the void. Voyager 1 will then become a cold, silent machine, moving endlessly outward. While its voice will fade, the machine itself will continue drifting through the star fields for time spans far longer than human history.